Question 8. The diagram below shows the triangles CBA and CDE. The coordinates of C are 4.50. From the diagram, write down the coordinates of the points A, B, D, and E. In our diagram, the horizontal axis is labelled with X, and the vertical axis is labelled with Y. To find the coordinates of our points, we simply need to read off the values on these two axes. By convention, we always list the X coordinate first and the Y coordinate second. So let's start with point A. We have an X coordinate of 1 and a Y coordinate of -2. So A is equal to 1, -2. Looking at B, we have an X coordinate of 4 and a Y coordinate of 2. So B is equal to 4, 2. The coordinates of D and E can be found in a similar way to A and B. Part B. Show, using slopes, that the line segments AB and DE are parallel. The key to solving this question is the following fact. Lines are parallel if they have the same slope. So the strategy here will be to find the slope of both lines, show that they are the same, and hence show that the lines are parallel. To find our slopes, we'll have to use the slope of a line formula on page 18 of the formula book. It says that the slope m of the line passing through the points x1, y1 and x2, y2 is m is equal to y2 minus y1 over x2 minus x1. We are concerned with two different line segments, AB and DE. We'll need to find the slope of each. Let's start with AB. From the previous part of the question, we know that A is equal to 1, -2, and B is equal to 4, 2. To use our slope formula, we should label our first point, A, with x1, y1, and label our second point, B, with x2, y2. To find our slope, all we have to do is sub into the formula. So we found that the slope of AB is 4/3. Now for the slope of DE. From the previous part of the question, we know that d is equal to 6, minus 6, and e is equal to 15, 6. We'll label our first point d with x1, y1, and label our second point e with x2, y2. To find our slope, we simply need to sub these values into our slope formula. So we found that the slope of DE is 4/3. Remember, we know that lines are parallel if they have the same slope. We have shown that AB and DE both have a slope of 4/3. Since they have the same slope, we can conclude that they are parallel. Part C, I. Show that the area of the triangle CBA is 4 square units. This question concerns the area of a triangle in the context of coordinate geometry. There's a formula on page 18 of the formula book which will help us here. It says that the area of the triangle A between the origin 0, 0, P is equal to x1, y1, and Q is equal to x2, y2 is A is equal to a half times the absolute value of x1, y2 minus x2, y1. We want the area of the triangle CBA. From the previous parts of the question, we know the coordinates of these points. A is equal to 1 minus 2. B is equal to 4, 2. And C is equal to 4.50. These 3 points define a triangle. Unfortunately, we won't be able to apply our formula directly. This is because it's very specific. It insists that one of the 3 points is the origin, 0, 0. To use our formula, we must translate our points so that one of them becomes the origin, 0, 0. Here, I will perform a translation to make A the origin. The first coordinate of A is 1. To make this a 0, I would need to subtract 1. The second coordinate of A is minus 2. To make this a 0, I would need to add 2. So the translation here is minus 1 to the first coordinate and plus 2 to the second coordinate. To ensure we're not changing the shape and area of the triangle, we need to apply the same translation to B and C. Now that we've translated one of our points to 0, 0, we're ready to use our formula. Here, we label the point 3, 4 as x1, y1, and the point 3.52 as x2, y2. So let's sub these values into our formula. The vertical bars denote an absolute value. This means that we must take the positive version of whatever's inside. So the absolute value of -8 is +8. A half times +8 is +4. Since this represents an area, our unit here is square units. We were asked to show that the area of our triangle CBA is 4 square units. And that's precisely what we've done. Part II. Find the length of the line segment AB. In other words, the distance from A to B. There's a formula on page 18 of the formula book which allows us to find the length of line segments. It says, given 2 points, P is equal to x1, y1, and Q is equal to x2, y2, the length of the line segment from P to Q is the square root of x2 minus x1 all squared plus y2 minus y1 all squared. We want the length of the line segment from A to B. The coordinates of these points were found earlier in the question. A is equal to 1 minus 2, and B is equal to 4, 2. To use our formula, we should label our first point, A, with x1, y1, and we should label our second point, B, with x2, y2. From here, it's a matter of subbing into our formula and doing some calculator work. Our final answer here is that the length of the line segment AB is 5 units. Part III. The triangle CDE is an enlargement of the triangle CBA. Given that the length of DE is 15 units, find the scale factor of the enlargement. Looking at our diagram, the triangle CDE and the triangle CBA have an identical shape. The only difference is that CDE is a bigger version. This is what the question is talking about when it says that CDE is an enlargement of CBA. We're asked to find the scale factor of the enlargement. Specifically, if we look at the corresponding sides in these two triangles, how many times larger will the side be in CDE? We can find our scale factor by comparing the longest side in each triangle. These are coloured in blue. AB is the longest side in the triangle CBA. In the previous part of the question, we found that the length of this side is 5 units. On the other hand, DE is the longest side in the triangle CDE. And we are told in the question that this side has a length of 15 units. So, if we compare the longest side in each triangle, we see that the side in CDE is 3 times larger. This means that our scale factor is 3. To summarise, the longest side in CDE is 3 times bigger than the longest side in CBA. So the scale factor is 3. Part IV. Use the scale factor to find the area of the triangle CDE. This area corresponds to the shaded region in our diagram. Well, from the previous part of the question, we know that CDE is an enlargement of CBA with a scale factor of 3. From C part I, we found that the area of CBA is 4 square units. So, we know the area of the triangle CBA. And we also know that CDE is just a scaled up version of this triangle. So if we scale up our area appropriately, we can find the area of CDE. The key observation is the following. Area is measured in square units, so the area will get scaled up by the square of the scale factor. In equation form, this says that the area of CDE is equal to the area of CBA times the scale factor squared. Well, we know that the area of CBA is 4 and that the scale factor is 3. When we calculate 4 times 3 squared, we get an answer of 36. So our final answer here is that the area of CDE is 36 square units.